Hello viewers, after a long time I have come to make a video. This is a UPS 600 VA, is the normal UPS that we find in a home. So a few days back I bought this UPS and suddenly I thought of upgrading its battery so that I can get a long backup time. So generally this is a customized and I don't suggest anyone to do it, but this video is totally for educational purposes. And what I have done is based on my technical expertise and my risk appetite. So if you are free to take such type of risk, you can go ahead. So let me come down what I have done. So this UPS comes with a battery of 7H, which is generally this type. Will find it in the market, that is inside the UPS. This battery was inside the UPS, and generally 600 VA small UPS is having this type of battery inbuilt. So what I am planning to install this battery of 26Ah, you can see 26. So if this was running for 10 minutes, so it is like 4 times, approximately 4 times. So I'll get around 40 minutes of backup as per my calculation. So what I have done, first thing is we need to install this type of wires that will externally fit the battery, and in the end you have to make some connectors so that you can give a termination to the ends of the battery. So this is for the battery purpose. Now coming inside the UPS is the wiring part. What I have done, this wiring has to be separate for the positive and the negative. I didn't find any kind of black wire in the market, so I have taken this yellow, which is the negative, and this is the red is the positive. So this I have replaced, which was inbuilt inside. If you can see it, the red and the yellow big wires. Earlier the wires that came up was this type of connectors, so that you can connect the battery with this, and those were installed inside this. So as we are installing a big battery, so there will be a there will be heat regulation issue, because this is not having any such type of heat regulation meant for this type of battery, because it is already calculated with this type of 7H batteries. Now since we are installing this big battery, so things will be quite difficult to manage the heat, and the most important part of circuitry is controlling of the heat, which actually damages your circuit or the electronic devices. So to resolve this, I have installed a fan that I have taken from a small SMPS, which you can also find anywhere, from a damaged SMPS. This was not used, so I have taken down the 12-volt fan and have connected a resistance of 57 I think 56k 1 watt, so that the fan speed is quite low than its average high speed, so that the sound is low, and as well as it is not having any kind of regulation of the speed. So this is a manual process that I have to do right now, because I couldn't find any sort of temperature sensors. there is a provision which I'm planning in the later stages. I'll be installing in this connector. There is a connector that I have taken out for the supplying of this fan, and this is the switch that I have taken to regulate the fan. This is a totally a manual process right now. So in order to keep my transformer as well as the MOSFET that are running from heat issues, I'll be using this fan. So before installing the fan, I made some sort of air ventilation holes that you can see it. Okay, so these are the holes that I have made, and earlier there were some holes already. This is a mesh that I have seen, and this will work as this inhale system, because here I'll be exhaling that hot air. As the hot air will get produced in the transformer, this transformer, this whole area will be getting heated up, and I'll be discharging this hot air by running this fan. So accordingly, there will be a positive pressure outside, and automatically from these vents, this will inhale the cooler air. So cooler air I'll be inhaling from these vents, and at the same time this area, this will exhale the hot air. So this is the design that I have taken in before planning, and later on I'll be installing here, as I said earlier, I'll be installing a temperature controlled fan control as a sensor. So this temperature fan control, what it will do, as soon as the temperature reaches a set point that will define in the later stages based on the calculation of the transformer, so this will automatically regulate this fan. Generally the fans, this type of fans that we find in the CPUs, this is having a speed control. This is we can find a speed control. This is in the CPU processor, but since this is not feasible to install inside this, since it is not a processor size, and we need a very big fan to accommodate this transformer, so we'll be using this type of fan. And I cannot find any sort of voltage regulator so that I can control the speed. So what I will do is I'll make a timing based circuitry. Sorry, not timing, it will be a temperature based control. Means as soon as it goes beyond my set point, I say it goes beyond 60 degrees centigrade, so this fan is going to start till the 60 degree is achieved, and again if it goes beyond 60, this fan will start. The circuitry will be enhanced in the later stages when I purchase the circuitry of that temperature module. So there what I will do is, the input will be the same of the 12 volts for the circuitry. This I will feed to the temperature unit, and in the temperature unit I will feed the fan unit. So this is the same. So the new circuitry will be in between these two terminals, and as soon as the probe that I will get to the temperature sensor, I'll place it somewhere here. I'll place it near to this. When the temperature cuts the set point, the fan will start blowing, and if possible I'll try to regulate the speed of the fan with the voltage control device, if I find any sort of device in the market, a ready-made, or I will have to make something. Anyway, so this was all about the upgrading your UPS runtime by installing a battery of 26Ah. You can install other batteries also. There are various variants. This is 7, you can find 9. If you use the 9 ampere battery, you can place it inside the UPS itself, because both of them are pretty same. After that we have, I think this Amron is having 12 volt 12 Ah battery, 12 volt 12 Ah battery, and after that it comes with 12 volt to 18 Ah, and after 18 I think it is the 26, so I'm using the 26. So this will take a longer time to charge, because UPS is meant for a smaller operation and the inverter is for a larger operation. Inverters operate throughout the day, but the UPS is for smaller period of time, for say 1 or 2 hours of operation. But since we are installing a bigger battery for 24/7 services, so this fan is very mandatory, otherwise the device will blow up. I hope this information given through the video will be useful to you, and you can also customize your circuit and I think achieve a great runtime. I will not suggest anyone to do it until and unless you have any special expertise, or you can do it at your own risk. And please give your valuable feedbacks if I have missed out anything, or you want to know something, or you have any sort of good ideas. I'll be happy to upgrade myself with your ideas. Thank you.